Okay, good morning. We're going to take a bit of a step back from where we were yesterday. I'm just going to take it a little bit slower. I've included the ministry expectations on this handout. Now, I'll sort of say up front, if you want to print the handout, that's fine. If you want to just use it as a reference and kind of make a similar table to what you'll be seeing down below in your notebook, or that's fine as well. If you want to download the sheet and just keep it as a Word file, that's fine. You want to recognize that with an investigation, it's like an experiment in science. The content is just kind of leading you to the final summary and sort of the observations. And so whether you have this specifically in your notes probably isn't a huge deal. If at the end you've got the concepts, that's of course what we want. So the expectations 2.1 determined through investigation. As I've mentioned before, there's a lot of the ministry expects us to do a lot of investigations for this sort of stuff. The idea being that you can easily graph this now, especially with graphing calculators and computers and so on being so prevalent in classrooms. And you should be able to sort of see patterns and develop from that an understanding that you might not get quite as easily if I just kind of tell you how things are going to look. So specifically, we're doing reciprocals of linear and quadratic functions. And reciprocal, in case you aren't sure, just means 1 over. So the very first graph here is going to be graph f at x, or y equals x, and the reciprocal, which is just y equals 1 over x, or g at x equals 1 over x. The reason we use f at x and g at x, of course, is just to keep it straight so that I'm not saying y in both cases. It's just a little bit nicer to know that you can decipher between them. Terminology, super quick. Vertical and horizontal asymptotes. If you don't remember, or you don't, for some reason don't know, obviously, you can punch them into Google and get a pretty good description. If ever you run into terms like that where they're just kind of thrown in and the expectation is that you should know them and you don't, of course, ask right away. You can't really do this assignment without knowing what vertical and horizontal asymptotes are, because they're basically one of the first couple things you run into. And my suggestion is, sort of the assignment says sketch the graph and its reciprocal on the same grid, and I wrote by hand or using graphsketch.com. I like graphsketch.com because it allows me to take a picture of this, and I can then copy and paste it right into the other file if I choose to. It's also a little bit nicer to adjust using, domain really here, and range. If the graph needs to get bigger or smaller, I can zoom in, zoom out using that a little bit more nicely than with the Desmos that I tend to like. So I've got y equals x squared here, y equals 1 over x squared. Just a quick note that in order to do these, you'll need to put brackets on in your denominator. At least if there's anything more than just 1 over x, you'll need to bracket the denominator. I don't want you kind of going through the whole thing and having all the answers come out wrong because you just didn't type it in quite right. Now, basically, over here, not too much. X range, Y range is, of course, just what's going to show up on the screen. The tick distance, you can see 5, 6, 7 going up by 1s or going down by 1s here, and going up by 1s as you go across in the X direction as well. And then the labels just kind of show up. And like I said, most of this probably you just leave alone unless you really want to zoom in a bit or zoom out because for some reason you don't see something well enough. So I plot this. It shows me my x squared in red. Sorry, my 1 over x squared in red and my x squared in blue. So the original looks like this, and then the new one looks like this. And again, if you need to sort of say, well, I'd like to see a bit more of that, let's make the y range 50, and then I can see clearly what happens with the parabola, and I can see this better as it goes out as well. And of course, if I wanted to clean it up, I could make my a few less grid lines along the way. Now, if I want to also click here to download the graph, it just makes a picture. When I open it up, I can copy that directly into this file if I choose to. And once it's in there, of course, I can shrink it down to make it a little bit more reasonable. Now, for the purpose of getting through the filling in the table, if I can't see this, obviously referring to the original, but the zeros, it's asking me where y is 0 on each graph. Well, on the blue graph, y is 0 right at x equals 0, so at the vertex of the parabola. And then g at x equals 1 over x. Where does y equal 0? Well, it's kind of hard to tell, but when I look here, and if I did want to zoom in, these red lines are approaching 0, but never actually crossing 0. Okay, so I don't know if how nicely it's going to work if I try to do this. Let's give it a shot. Okay, so sort of approaching, can't really tell, but not crossing 0 anyways. So it's not perfect, but hopefully we understand that's what's going on there, which means that if I go back here, there's simply no values here where y is 0. And then that means that actually answers my question for horizontal asymptote here. Horizontal asymptotes are lines that we can't cross, horizontal lines that we can't cross. And so the line y equals 0 is one that we don't cross. Just sort of a follow-up from the previous one here. Vertical asymptotes, of course, are the opposite. There are vertical lines that we don't cross. And again, can't see it super clearly with that. But these lines, so I've zoomed in, it's not a good thing. But if I'm not sure, make the y range much higher. And these red lines look like they're pinching in but not hitting each other. Again, same sort of idea. There's a vertical asymptote now when x equals 0. So my red lines, my reciprocal function, never crosses x equals 0. And then basically you're just going to go through and fill in the blanks. Where does y equals, or where is y greater than 0? Look at the graph. Well, actually, in this case, y is greater than 0 all the time. The y values are all above 0 here. They're all above 0 over here. Same sort of thing with the original. And so, I'm basically looking at the ranges here. Y is greater than 0 all the time. Y is less than 0, never, something along those lines. And of course, in the end, what we're hoping to do is see patterns between what happened in this column and what happens in this column. Now, just sort of in case you missed it, those aren't your answers because I wasn't graphing x and 1 over x. I was graphing x squared and 1 over x squared. But the process will be the same for you. Now, I'm not sure if I said this or not, but you can choose to just to copy this down in your notes. You can choose to print this off and work with it as it is. Or you can choose to edit it and just save it again. The process again is sort of just going through the steps to get to your summaries, to get to the understanding of what you've seen, and then you'll be applying that in order to sketch graphs yourself. So it says basically complete the similar table for those ones, and then write a quick summary of your findings. Make it sort of here. Be sure to make a distinction between linear and quadratic functions if appropriate. So if you notice that all the questions that are linear, this is what happens. The horizontal asymptote is similar to the such and such. Great. If you notice that for quadratics something happens or something different happens, then make sure you sort of make a note of that. And then there'll be a posted set of questions, some just out of that, again, the textbook. For some reason I haven't got your new textbooks yet. And the answers will be there as well. So I'm going to stop there. Hopefully this will be a little bit easier than yesterday because you are just starting by graphing and I'm doing the observations. And as we go over the next couple of days, graphing things will become a whole lot easier, I hope. Thank you very much, and I'll talk to you later.